So in this lesson, we are going to look at solving systems of inequalities, which is going to require shading, solid, and dotted lines. So here's a problem that's already finished for us. I'm going to make it a little bit bigger so that we can all see what's going on. Okay. Oh, it's a little crooked. Maybe not. I don't know. It looks crooked to me, but there we go. Okay. So first of all, as we're looking at a system of inequalities, you've got solid versus dotted line. So here's a dotted line, here's a solid line, and then this is just the shading of where the shadings intersect. So it's only the solution. You don't see all the shadings. So I'm going to try to show you all of the shadings here in a minute. And plus, these inequalities are not solved for y. So you still have to have the inequality in slope-intercept form, even though you have this less than or equal to sign or greater than or equal to sign. So just as a bit of a review, if you have a greater than or a less than sign, you're going to have a dotted line. If you have a greater than or equal to sign or a less than or equal to sign, you will have a solid line. It's kind of like open and closed circle on the number line. And then I'll review how, if you're struggling with shading, there's a couple things you could do to kind of make it seem to make sense. So let's start off by solving this first equation here for y. So you can see, so I'm going to label this as equation 1. And so I'm going to do that down here. So I've got 2x plus y is less than or equal to 8. So when you solve an equation, an inequality, the only thing that's different than solving an equality statement is if you multiply both sides of the inequality or divide both sides of the inequality by a negative, you have to flip that sign. So I'm going to get that by itself, so I have to move the 2x by subtracting it. Subtracting doesn't cause you to flip the inequality sign, only multiplying and dividing. So I get y less than or equal to, I want it in the slope-intercept form, so the x term must come first, and then plus 8. So my y-intercept is 8, and my slope is -2 over 1 or 2 over -1. And so you can see how this was graphed right here starting at 8, and we went down 2 to the right 1, down 2 to the right 1, and so forth all the way down. Because we have an equal to sign here, we have a solid line, and our shading, because our inequality is less than, our shading needs to be below. If you're struggling with that, you can always put yourself, so if I drop myself on this line from up north right here, so if I drop myself from the top onto the line, I'd land somewhere on this side of the line. So I'm going to put myself there. So think of this line as a mountain. If this were a mountain, you would have to stand on this side of the line, because if you stood over here, you'd be buried, right? So on this side of the line is where you bury things underground. This side of the line is where the sky and the sunshine is. So this is above the line. So if I am going less than, I want to shade below the line where things are buried. So I'm going to show you the actual full shading. So the full shading would be all the way down here. Okay, so then let's look at the red line. So I'm going to actually change this to blue, and then I'll do this one as your red line. All right, so the second line is this one. So you've got 2x minus y greater than 1. So again, we're going to solve this for y. The y is negative, so the 2x is positive, so we have to subtract 2x and subtract 2x. So we get a negative y greater than, and then your x term has to come first, negative 2x plus 1. Then remember, y has a coefficient of negative 1, so we have to divide everything by a negative 1. When you divide by a negative 1, this sign right here has to flip because you're dividing by a negative. So immediately I'm going to change that greater than to a less than sign. Okay, so it flipped, less than. And you've got y less than, two negatives make a positive, so 2x, and then minus 1. So for this line, your y-intercept is negative 1, and your slope is 2 over 1, or negative 2 over negative 1. So they started at negative 1 here, and they went up 2 to the right 1, up 2 to the right 1, and so forth. And you can see the line is dotted because you have no equals to. So we have a dotted line. And because you flipped your sign, it's no longer greater than. Your final answer here is a less than, so we have to shade below. So if I'm standing on the line, if I were to drop myself from above onto the line, I'd land on this side of the line. So for the red line, I'd be standing here. So if I need to be below myself, below me would be down here. So that's where my shading is going to be for the red. So I'm going to shade down here. And you can see where the two shadings intersect right here. And so I like you to put a great big S where the solution is so that we all are clear as to where you think the solution is. So anything that is on this solid border right here, and anything in the shading, any ordered pair, is a solution that will make both of these inequalities true. This is a dotted line, so no ordered pair on this dotted line will make any of these, will not make both of the inequalities true. So you can't choose anything that's on the dotted line, only on this solid line or anything in here. Here we go. So we've already talked about how to graph it. So I already went through this procedure. So as you can see, we solved each inequality, put it into slope-intercept form, flipped any inequality sign if you multiplied or divided by a negative, graphed, determined whether you had solid or dotted line, and shaded, and then the solution was where the shadings intersected. So let's do this one together. And I'll let you do the next one on your own. So we're going to solve the system. You need to solve it for y. So I'm going to let this be equation 1 and this equation 2. So let's start with 1 down here. So I've got x plus 2y less than 8. I'm solving for y. X is positive, so I'm going to subtract x. So I get 2y. Inequality stays the same. X term comes first, plus 8. You got to solve for y, divide by 2. Nothing causing me to flip a sign. So I have y less than. If you take x out of this fraction, you've got a negative 1 up top and a 2 on the bottom. So I have negative 1/2 x. 8 divided by 2 is 4. So my y-intercept is 4, and my slope is negative 1 over 2, or change both signs, 1 over negative 2. So let's go ahead and plot that in stair step. So I'm going to plot my y-intercept at 4, and my slope, I'm going to go down 1 to the right 2, down 1 to the right 2, and so forth, all the way across. Then I'm going to go in the opposite direction, up 1, but to the left 2, all the way across. Now we have to decide to connect this with a solid or a dotted line. Because we have no equals to, we're going to connect with a dotted line, and because we have less than, we are going to shade below that line. So let's do those. So please use a straight edge. Let's see, I'm not going to be able to do a dotted line on here, I don't believe. Isn't that special? All right, so for my dotted lines, I'm going to have to hand draw those. So they won't be perfect, but hey, what the heck. So, oh yeah, that's awesome. Here's my dotted line and my arrows, okay? Then if I were to drop myself from the top down, I would land on this side of the line, would be considered the top of the line, because look, here I am. I'm going to put myself in red. Here I am standing on that line. If I put myself down here, I'd fall off the line. So this is like a mountain, right? So this is above where all the air and sunshine is, and this is below where you would bury things. So we want to shade all the way down here because we're shading below. So here we go. Here's all my below shading. So everything down here below satisfies that inequality. Okay, so then let's look at the second inequality. So number 2, we've got 3x plus 2y is greater than or equal to 4. So I'm solving for y, so subtract 3x. I get 2y greater than or equal to negative 3x and then positive 4. To solve for y, you divide by 2, divide by 2, divide by 2. Everything gets divided by 2. Nothing causes me to flip that inequality. So I have y greater than or equal to. Take x out of the fraction. You have negative 3/2 x. 4 divided by 2 is 2. So I have a y-intercept of 2 and a slope that is negative 3 over 2, or change both signs, positive 3 over negative 2. So let's stair step that. Start at 2. I'm going to go down 3 to the right 2. Oops, I want that to be blue. Down 3 to the right 2. Down 3 to the right 2. And now we're going to go in the opposite direction. I'm going to go up 3 from the y-intercept, up 3, and to the left 2. Up 3 to the left 2. Then I'm going to connect those with a solid line because we have equals to. So solid, and I have a greater than sign, so I am going to shade above. So let's connect first. Okay. So here's my solid line. And then my arrows. And then if I were to land from the top onto this line, if this were a mountain, here I am. So if I'm going to go above is where the air and sunshine is, that's all up here. That's where the air and sunshine is. So I would be in the shading. So all of this is where the air and sunshine is. So then the solution is right in here where the two shadings intersect. So I'm going to label that with a great big S for solution. That's all there is to it. All right, so I want you to graph this on your own. We've already done 2 together essentially, so pause the video, graph this one on your own, and then restart the video and check your answer. So I'm assuming you're checking your answer, so I'm going to go ahead and do the work. So this is equation 1 and equation 2. So because this is equals to, you will have a solid line and less than below. So we will have solid and below. So okay, so then my shading, let's say that I were to drop myself onto the line from above. I would land on this side of the line. So below me would be all of this. So that's the first equation. The second equation is already solved for us. Yay, less work. So for this one, again, I have an equals to, so it's solid, but this means above. So solid and above. So let's graph the line. Oops, I totally missed that one. I'll have to fix it. There, that's better. Okay, so then if I were to land on the top of the line, I would land here, just my little person. So above me means where the air and sunshine is, so it's all of this above here. So here goes nothing. So as you can see, the two shadings intersect here. So big S goes here. Again, I would like you to solve this system on your own, or graph it and solve it, and then, so pause the video and then I'll do the work for you. So at this point you should have already graphed this, so I'm going to zip through the solution. So this is inequality 1 and inequality 2. So solving inequality 1 for y. Okay, so then I am going to connect this with a solid line because it equals 2, and I'm going to graph below or shade below. So solid and below. So let's connect this. I'm going to fix that so it's better. There we go. Okay, so arrows. Then if I were to drop from the top onto the line, I would hit right there. So below me is where things are buried. So below me would be underneath the ground, because this is the mountain. So here's my shading, all of this. Okay, next, equation 2. So this one, fortunately, is already solved for y. So your y-intercept is -2, and your slope is 1 over 1, or -1 over -1. So plot at -2. Sorry, they are working on the bell system. So that just means we all get to hear them. Yay. Okay, so now I'm going to connect. Because I've got equals to, I'm going to have a solid line, and then greater than means above. So solid and above. So if I were to be dropped, well, let's do the solid line first. So I'm going to put in my solid line. Okay, arrows. And then if I drop myself on this line, I would land on this side of the line. So above me is where air and sunshine is, so I would be in that shading right here. So here goes the shading. Air and sunshine. It's kind of like coloring in kindergarten. There we go. And so the intersection of the two shadings is right here. Whoops, let me put that with pen. The intersection of the two shadings is right there. There's your solution. Then we come to word problems. So your job is going to be to define your variables, write two inequalities with two unknowns, and then to solve them. So I'm going to show you what the graph looks like. We're just going to write the define the variables and then write the equations. So let's read the problem and highlight things that are important. So first and foremost, tickets to a concert cost $70 or $20 with a student discount. So those are kind of important numbers. So if I were you, I would probably circle 70 and circle 20 with a discount. That could be important later. Ticket sales must exceed $50,000 for the group to perform. So again, that's what we would consider a constraint. So ticket sales must exceed $500,000. Also, if 20,000 seats are available, that means there are no more seats available. There are fewer available, but no more. So we have to sell more than $500,000, and we're constrained by only 20,000 seats. So that's another constraint. So how many of each type must be sold? And so you're not going to do the solution on your calculator. I know. You are going to do it on your own, and I'll talk you through it. So you have to define your variables. So we like to use X and Y. You could use S and T or M or whatever you want to, but you have to decide which one's your independent variable, which would be on the X-axis, and which one is your dependent variable, which would be on the Y-axis. In this case, the two things that make a difference would be, in order to make our $500,000, we have to sell tickets. We have two types of tickets: regular price tickets and discounted tickets. So in order to figure out this $500,000, I would have to take the number of normal priced seats that I sold and multiply it by 70. And then I would add to that the number of discounted seats that I sold multiplied by 20. So we're going to let X be the number of $70 seats sold, that's your normal price, and we're going to let Y be the number of $20 seats sold. You could switch these around if you wanted to. In this particular case, it doesn't matter. So that's your first step, is to define the variables. Then the next step is to write your equation. So let's work with the $500,000 first. So to get the $500,000, I have to take $70. Whoops, I want that in red or black. So I've got to take $70 and I'm going to multiply it by the number of seats that I sold at $70. Then I would add to that $20 multiplied by the number of seats that I sold at $20. Then the keyword here is exceed. Exceed means that this value here needs to be bigger than 500. It cannot be equal to, it has to be bigger. So bigger would be a greater than symbol, $500,000. There the bells go again. All right, so then our second inequality is going to be dealing with the 20,000 seats. The number of $70 seats plus the number of $20 seats cannot exceed 20,000 seats total. So that's a constraint. So we've got X plus Y, the number of each types of seats, has to be less than or equal to, because I could sell up to 20,000 seats. So in this particular one, I could have an equal sign. So there's your system. Then to graph it, you're going to have to solve each equation for Y. So just like we did before, don't worry that the numbers are big. So for the first inequality, I'll show you how to deal with that. And you can do this all without a calculator. Okay, so I want to get the Y by itself, so I'm subtracting 70X. And I get 20Y greater than negative 70X plus 500,000. Solving by dividing by 20. Yes, you can do this without a calculator. You got this. So Y is greater than. These zeros are going to equally cancel, and you're left with negative 7 over 2. A nice little trick. So negative 7 over 2x. And then this 0 can cancel with one of those zeros, and you're really left with 50,000 divided by 2. So 50,000 divided by 2 is 25,000. Now, if I were graphing this, clearly my y-intercept is 25,000. So you don't want to go by ones. You probably don't want to go by, and this is your y-axis, you don't want to go by 1,000 because 25, you'd have to go up to 25. So you don't want even that. So I would suggest you go by fives. So every hash mark is worth 5,000. But before we decide that, let's see what our next equation gives us. All right, so 2, our second equation, x plus y, this will be easier, is less than or equal to 20,000. So I want to solve for y, so subtract x. And that will solve for y for us. So we get y is less than or equal to negative x plus 20,000. So this one's going to cross the y-axis at 20,000. So I think having a y scale of 5,000 each would be good. And then you've got to stair step a 7 and a 2 and a 1 and a 1. So I would make your x scale go by 1s, which is okay, and your y scale go by 5s. In addition to that, we really have some more constraints which will bring us into linear programming in our next video. But right here, the number of seats sold can only be positive numbers. So really, we're looking at the first quadrant. You don't even have to graph anything in quadrant 2, 3, or 4. So I would just make just a first quadrant, and these are going by 5s, and these are going by 1s. That's not an x, that's going by. Okay, so then you'll graph it. The next slide that I show you is going to be actually the graph of it. And here's what it would look like. Now this particular graph shows the negative values as well. But if you graph these, then you can see that anything in here is going to make the solution true. So if you chose any combination here, like, I don't know, let's choose like this ordered pair right there. All I have to do is figure out the x and y value, which is hard to tell on this picture, and then that would tell me my number of combinations. So maybe I sold 15,000 regular price seats and 5,000 discounted seats, something like that. But we'll get more into that with our linear programming. So this should get you through your homework. If you have any questions, just let me know. Have a great day.